Dad, why do we have custard on the bench?
You're going to be making some custard in a minute. Guess why?
Maybe it's because it's a non-Newtonian fluid.
A non-Newtonian fluid, yes. Now, the shed hackers may not know what that means, but it's quite important, perhaps part of this clip, that they may understand that. So we'll go on to that. Any other questions of what are the things we're looking at on the table here?
Yeah, what's this fluffy stuff?
Okay, this is glass fibre. And glass fibre and matting in small amounts like this is put into concrete to reinforce it. The same way as steel is put in as reinforcement. Some people know it as rebar. But yeah, very clever. And that's a fabric they're putting. But they are microscopic strands of glass.
Wow.
That is. Doesn't look like it, but it is. Okay. Also used in insulation, isn't it? What else do you want to discuss?
Is that wire wool?
Yeah, look. Another unusual material. It's actually wool made from wire, strands of steel.
Wow.
Yeah, and that can be used for smoothing metals, all sorts. It can be woven into all sorts of products. Okay, wire wool. And this, what do you think this is?
Would that be from our video on smart materials?
Well, it is a smart material in many ways. This is carbon fibre filament cloth, and this is used in all sorts of new products. Very, very light, but extremely strong when mixed with a resin. And the resin they use is usually a type of epoxy type of resin. Okay, so when it's mixed with that, you can actually make a very, very strong and resilient and tough new material. Okay, any other comments?
Yeah, would this actually be strong?
Well, this is made from beechwood. Beechwood has hardly any knots in it where the branches come out. Yes, it's very, very tough.
Wow.
And that's a thread there being cut onto the piece of beech there using a lathe probably. And yeah, years ago this would have been used for all sorts of purposes in manufacturing. But yeah, that would be very tough, amazingly tough. But wood is still extensively used for all sorts of products, not just furniture.
Wow. Can you demonstrate some of these properties?
You mean the physical properties?
Yeah.
Which one would you like to start with?
Maybe fusibility?
This one here. It says the ability to be fused or converted from a solid to a liquid. And it says can be easily cast. Or can be cast easily. That's an interesting one, and I think that's one of the harder ones to explain. But I suppose we could start with this tyre here, Jake. This tyre here is, I'll just take these gloves off because I'm going to demonstrate something in a minute. This tyre's been vulcanised together, and that's made from several layers of plastic. It's a rubberised elastomer, and that means it can be stretched, of course, but you can see the joint there. The flashing, it's called, actually, the joint between the two injection molded parts together. But yeah, that's a clever piece of technology. And there's layers of, obviously, well, you won't know this, but there's layers of metal in there, and in some of them it's just nylon. In fact, you can see the material on the outside is a nylon, it says it there. Okay, so, but I thought perhaps if I talk about something being cast, you're thinking about things that are perhaps, you know, cast at low temperature. But other things can be stitched together, can't they?
Yeah.
So if you can't, you know, almost melt them and glue them together, they can be stitched together like this, a bicycle seat.
Could you melt or glue stitching or fabric?
You can, and there's an example. That's been, in a sense, sealed and vulcanised together, it's called. Cast as a ball. You can see the join there, look, where the metal mould it came from showed the seam, the two parts that came together to form the ball inside. And that's part of the injection moulding process, which is in one of our clips earlier, isn't it? Mm-hmm. So going back to it, if you scan across to here, Jake, this is two pieces of about 2mm mild steel, which is obviously a metal. And I'm going to show you that most things can be actually melted at certain temperatures. So it can be easily still formed into a shape, but it just depends on the temperature.
So when you said melted, can you melt everything?
And no, some things, once they've been formed, they can't be reformed. And we talked about certain types of plastics, certain types of thermoplastics, that thermosetting plastics, that once it's formed, it can't be reformed. But thermoplastics can. But going back to this, if you scan across to this machine here, this is a spot welder, and I'm going to break this apart and I'll show you how you can actually melt in a very small spot two pieces of metal together to form a joint. But it's sort of melting it to form a shape, isn't it? So it's fusing two parts together. So we'll come back to you in a few seconds on that one.
Is that a real laser?
It is a real laser, yes. We'll talk about laser light possibly. Another electronic device developed over the years. We could talk about some of these now to start us off on this next clip. And this is all about physical properties. Can you get that word there, Jake? Physical properties there. And it's the makeup or structure of the material. What really makes that material have certain qualities. I need to hold this steady now. So we could start a little bit, just start off on absorbency. The ability to allow a liquid to pass through it or store or hold a liquid. Okay, that means any liquid depending on the product. So that glove is not very absorbent. But that there, what's that, Jake?
Sponge?
That's your famous sponge from the Cake movie.
Oh yeah.
Okay, so that is a good absorber. It does allow water to pass through it as well. It has some really quite impressive qualities, that. But other materials such as rubbers and certain metals are not good absorbers.
What about bread?
Bread is good at absorbing water and other sort of liquids, isn't it? Okay, should we move on to that biodegradable one? That's quite a tricky one. Biodegradability is literally meaning that, does it degrade if you leave it in an outside environment over time? And things can be developed to degrade or fall apart, if you like, over a period of time deliberately. And it's used in medical science, where they put stitches in people, obviously if they've been cut, and the stitches naturally deteriorate and biodegrade. Isn't that clever? And it's used in normal pharmaceuticals, in tablets, where tablets release chemicals slowly. So lots of new, uses for biodegradable material. Density, everyone knows, I hope, it's the weight relative to the volume. Okay, so how heavy something might be. It usually relates to the mass of the product on planet Earth. What's that? That's a funny old word. Fusibility. What do you think that means?
Maybe ability to be fused or converted from a solid to liquid?
Yeah, it's a really hard one to explain. It really relates to whether it can be easily cast into a shape and joined easily into itself and onto other products and materials. That's quite a hard one, fusibility. Bit of a research topic, perhaps, for some of our viewers. Okay, electrical conductivity. Pretty easy, I think. Allows electricity to pass through it, or not. So if it's highly conductive, it allows electricity to pass through it easily. And if it's not electrically conductive, it resists the flow of electrons. And we'll touch on that because we're going to talk about these sort of things, Jake, in a minute.
Wow.
And I've taken apart a handheld phone there to show some of the componentry and circuitry. Okay, so moving back. Thermal conductivity, did we touch that? We talked about the spacecraft, didn't we? Not allowing heat to enter the space capsule itself. Very, very important in space technology, but also important in electronics to stop heat getting to the circuit and damaging it. But also in, of course, clothing. Really important these days, especially if you're going up high mountains or high altitudes. Okay, we'll come back to shed hackers. Deliberately really good conductors, and electrical wire, I think I showed in an earlier clip, is designed exactly for that. The insulator, there's the plastic insulator, prevents the wires conducting electricity between themselves, but one isn't insulated. That's the earth wire there. I'll just put this down, and there's the earth wire, and that is deliberately not insulated, and you have to sheathe that when you do, or cover it when you do your electrical work, to make it safe. But there's a reason why it isn't covered. But yeah, so you've got a combination of metal and plastic there, The copper is a very good conductor, and the plastics are very good
Conductor. Oh no, sorry.
insulator.
Insulator.
Yes, Jake, you had a question.
So would that be very hard to recycle?
No, strip off the plastic insulator, you're left with all the copper.
Oh.
Yeah, sadly, a lot of people steal this sort of thing. Okay, so that's conductor and insulator. And actually, on that point, here's a propeller that was made by my father years ago. And it shows how strong and resilient, even going back to the point about woods, it is. And propellers like this were used many years ago, and they weren't even made from steel or any composite material many years ago.
What is this machine, Dad?
Well, this is the spot weld for joining metal together, and it's designed for ferrous metals, those containing iron, one for those shed hackers from an earlier clip. And I'm going to just put this in here, and the electrodes, which carry enormous amounts of energy, electrical energy, will fuse the two pieces together. Okay, actually melt the metal at some point. You can see I've melted it before, and it's actually burnt a hole. So let's see. Let's see what happens. Ready? There we go. And you often see these on cars if you look on the inside of the door panels. That's melted, look.
Wow.
So that's fused it together.
That's amazing.
At very high temperature. Probably about 1,000 degrees, more. Probably about 1,400 degrees. It's melted right through. Still break it. I might try one more, Jake. See if I can really join them together. Whoa! It's a bit frightening. Right, look, it's melted a hole in that one.
Oh my god.
Yeah, good though, isn't it?
Yeah.
Now, have you had I can't break that apart now.
Oh.
There you go. But if you had 3 or 4 of those in a line, that would be
really strong.
Yeah, it'd be as good as a bolt, wouldn't it? I could do another one. And then one here, maybe.
Having a bit too much fun there.
Yeah, it's fun, right? Yeah, melting it. And then I'll do another one.
You can see it be red hot.
Yeah, and one. Do you see that?
So can we cut some things?
Yes, and I suppose cutting is really to do with this word here called shear, ability to be able to be cut. Okay, and I know our viewers have been looking at some of the clips we've been doing on hardness testing, and we've been doing some destructive testing here. And this book here, Jake, it talks about the tests you can do, scratching and so forth, and bending, and looking at the properties of materials. But there are scientific tests you can do in a laboratory, which shows how you can test for toughness. And there's one there, and that is the Vickers test, I think. Oh no, it's a Rockwell. Oh, and Vickers, yeah. But there's lots of other scientific tests you can do in a laboratory, as well as the ones we did. And we did one on, I think it was the dot punch test for hardness, didn't we? But there's lots of other ones, malleability and ductility. We'll bend some metal perhaps later. But going back to this one here, this book here, there's a little bit there on how you can plot what we call stress over strain. And in a later clip, I'm going to talk to you about these two diagrams for the more advanced viewers. Okay, so you wanted to cut something, and let's buzz things up a bit. And we're going to be doing shear on this clip. Shear. So what shall I cut first, Jake?
So you're going to use scissors?
Well, sort of. They're called tin snips, and they're for cutting metal, plastic, wood, and everything really. Do you want to go through? Shall I go through what we're going to cut? See if you can name them. What's this?
Tennis ball?
Yeah, it's a polypropylene type material, and this is an expanded foam type of plastic.
Isn't that from a filter off a Hoover?
It is, yeah, it is polyethylene. We're going to cut some material. Oh, what's that material?
Is that from an animal?
It is. That's the skin of an animal. That's leather. Very thick hide. Yes, and we're going to try and cut that. What do you think that is?
Expanded polystyrene?
Yes, and the PS is polystyrene. That's expanded. It's got air inside it. Well, they pumped it with air and then let it harden. And that is the high density version of that. I know it's been coloured yellow, but you can get white as well. So that's the no aerated version of it. Okay, fun, isn't it? That's probably a lot less plastic there than there, and then it looks bigger. There's all the air inside it. There's another version. This is a PVC from some house decoration on the outside, the weatherboarding. I'm going to cut that near the guttering. That's pretty tough stuff. There's some rubber. That's an elastomer, polybutylene. There's the filament matting from carbon fibre, but it hasn't been mixed with the resin, so it's probably not a fair test. That is a... What's that, Jake?
Your sock?
No, I think it's one of yours.
Nah, it's yours.
Oh, better not tell Mum that. Okay, and we've got some... This is silver plated wire, so underneath it may well be just a steel, but it's silver plated. This, you may recognise this.
Oh, it's a brake cable.
It is a brake cable from a push bike or cycle. Nylon cord from a strimmer, cutting grass.
Seems a little flexible.
You see all this sort of thing used in clothing as well. And what's this?
A tree.
It was a tree once. It's paper, obviously, and we're going to see. We've tried to treble it up to make it the same sort of thickness as all the other products, and that's important. That physically they are, in a sense, similar thicknesses. What's that?
CD.
No, CD. That's
or DVD.
What's that? Is that polyethylene?
I don't know, but it's very clever how they make
I
them.
think that could be a polystyrene. No, polypropylene even. That's an acrylic. Okay. That's a type of styrene. Absolute styrene. What's this?
Cardboard.
Just a bit of cardboard. That's made from a tree again. It was once. That's a piece of plywood.
Well, I think it's called flexi-ply.
It is, yes, I can. That's 2mm, 3mm. Bit of 2mm. What's that material?
Aluminium.
Aluminium, yeah. That one I can't bend. What do you think that is?
Steel.
Yeah, steel. Mild steel. What's this?
Inner tube.
Yeah. Butylene. Yeah, rubber. Okay. What's this?
A mirror.
It is a mirror.
Or glass.
Yeah. Okay, so we've covered those. Is there anything else there? We're not going to cut the seat, but we can show how it's been stitched together. I want that because I know we've got viewers that study their textiles. What's this bit of... I think this is vacuum formed. Styrene again.
A bit of packaging.
Oh, polyethylene. Look, PET. Yeah, there you go. So, right. And then some hardboard there, some wood there. So we're going to give it a go. There's a bit of wood there from our Shed Hacks logo.
Yeah.
And that's plywood. Okay, made from layers of wood. So let's cut a few.
Yeah.
Ready? This is the aluminium. I'll use these tin snips. Ready?
Wow.
Oh, it's quite soft. Quite
Was
soft.
that easy?
Yeah, it was. Let's see about the steel. Oh, blimey, that's tough. That's tough. That's steel. That's
So that was really hard to cut.
that was hard, very tough, hard to shear. What's this?
Copper.
Yeah, we didn't mention that. Copper, bit of copper there. Yeah, not a policeman, bit of metal copper. Oh, there you go.
That
I won't
sounded
tell my,
like a suffer.
won't tell your sister that, because she's a policeman, isn't she?
Is that softer than aluminium?
A policewoman she is, actually. Sorry.
Is that softer than aluminium?
No, slightly harder.
Okay.
So it's harder than the aluminium, but not as hard as the steel by any chance. That's the other metals, I think.
Well, why don't we try and cut these scissors?
Oh, no, 1 minute. What about, shall I dare cut the glass?
Yeah, I mean,
All right, watch yourself. Goggles on, don't do this at home. Oh, it does cut. Right,
Yeah.
brittle. But it doesn't really cut, does it, as such?
it just...
Not really.
It breaks.
Yeah, I'm surprised I did that. Right, okay, so that's glass.
So was that easy?
Yeah, that was it. It was easy, actually, and a bit dangerous. This is the styrene sheet. Easy peasy, lemon squeezy. That's lovely. Right, bit of that. That's the styrene sheet. Bit of nylon wire, same sort of thickness. Oh, that's quite tough. Oh, look at that. Look, resistant to any sort of shear. Oh, that's quite impressive.
So is that why they would use it in a strimmer?
Yeah, and that's why they use it in rope as well. I'll get a little bit of nylon rope, if I can find it. Oh, it's gone. It's gone
It's
missing.
over there.
Oh, yeah. This is the filament based. It's made from lots of filaments. Little very fine filaments. This will be hard to cut. Oh, yeah, it is. It doesn't want to cut. It's very good in
I
shear.
noticed if you want to cut it, you have to keep tension on it and cut it very slowly.
It has to be very sharp. What about this? This is a bit of the expanded polystyrene. What do you think?
Easy.
Yeah, pretty easy. Pretty easy. Bit of paper, Jake. What do you think?
Maybe.
Oh, it's very easy. Paper's very easy to cut, isn't it? Very easy to cut. I mean, shear action is usually associated with shear scissors, isn't it?
Yeah.
Shearing. Scissors.
Or maybe the shears to cut the lawn.
Yeah, that's why they're called shears. Good point. Now, this is a bit of butylene rubber. Oh, that's good. That's hard to cut. It's not even trying to cut. And they're pretty sharp, those.
So then what about an inner tube?
Well, that's interesting. Oh, that doesn't cut easily either. That's similar material, see?
Oh.
Look, it really doesn't want to cut. Cut
Look,
at the end slightly.
At the end.
Perhaps a little bit more sharper, but it's actually sharper here, I know. That's interesting, that. That's butylene. Paper cuts. This is the PVC. What do you think?
It's going to be a bit brittle.
Do you think? I don't know. I think it's tough as nails. Look, that cuts lovely.
Oh.
Yeah, that cuts very well.
So it wasn't brittle?
No, not really. Not at all. Remember the PVC water pipe yesterday? Couldn't even crack it.
It was just
With
bouncing.
a hammer. Well, what about the? This is a mixture of cotton and polyester. So it's a mixture of, actually, in effect, oil-based fabric and natural fabric from cotton. Cotton's grown in bushes, buds in bushes, not trees, bushes. Okay, so let's. Pretty good. And that's why it's used. It's very good in wear and it doesn't shear.
I think though, if you had it in tension, it would cut better.
Yes, it would actually. It's a very good point.
Just like this nylon rope.
Yes, it does. The properties slightly change in the condition it's left in or tested in. Good point. That's why certain materials are not best left in certain under certain forces, because they can actually more easily damage. Now this is a bit of the woven metal wire. It's a woven cable, if you like. Can you see the little cables? Can you see them?
Mm-hmm.
Yeah. And they're steel. This is steel. Well, you can get stainless steel, don't you? Of course, that won't rust. Do you think it will cut?
Yeah, but not easily.
Not a chance.
Oh.
Not a chance. This is tough stuff. That's why it's used on in a massive version, not on a crane to hold the load.
Wait.
Look, it's hardly even damaged.
So try cutting it at the end of the tin snips.
I will. It won't.
Like at the very front.
Well, it can if you get just a single strand at a time. Yeah.
Or whether the end of the tin snips are stronger.
Well, I know they're sharper here. Actually, I know they are. But it can cut. But you have to get it. You have to shear it or cut it right across its cross-sectional area, right across the ear, not down it, across it, like that. That cut, and it's good to cut one piece at a time. Easier to cut. So that means the silver. This is solid, but it's much thinner, so it's not a good comparison. But I think this will cut. Yeah, it cuts easily. Okay, what about the carbon fibre
that won't
matting?
cut very easily.
No, I don't think it will. And when it's mixed with resin, this stuff is tough as nails. Oh!
What?
Well, I'm surprised I heard it cutting.
No. I think that may just be some friction. Oh,
no, it's cut.
It cuts at the end.
Yeah, because I know what it is. You see those filaments there? Yeah. They're thinner than human hair. Probably 10 times thinner. They are actually made from what?
Carbon atoms?
Yeah, they are. It's just pure carbon. So it's only good when it's mixed with a resin. And that's what makes it an enhanced material. That's a really good one for the viewers, actually. So on its own, as a single proper material, the properties aren't enhanced. And we've just proven that. Also, I can stretch it and you can compress it. I can compress it into a blob. That's a good example of how, if it isn't combined with its other material, it's actually not enhanced in any way. It's actually not so great. But still you can stretch it. It is very, very strong, like Kevlar. But look at the way it's woven very carefully. And this is obviously a man-made product.
So
they all
can
are
you
probably.
cut that donut?
Yeah, yeah. Who's been eating this, eh? Homer, do you think?
Yeah.
Look, oh, it's foam, yeah. And that's an expanded polymerized plastic.
So it's very good for filtering out dust and...
It could be a butylene, again, sort of an expanded version of a rubber, because you can stretch it and break it. Look at that.
Yeah.
The qualities of this foam allows air to go through and dust particles to be kept on one side, and this can actually be quite resilient in certain temperatures as well, and it can be cleaned in water.
Yeah.
So it has lots of different properties, this. It's quite a clever product, foam, okay, and it's probably only been around about 50 to 60 years, the sort of modern foams, I noticed. Okay, right, I think we've done, oh no, we haven't done the shed axe logo out of plywood. That's a layers of wood, like the car. If you just scan onto there's layers of wood, that's plywood. That Mustang we're making is, so let's see. It's very tough.
Yeah.
It's very tough plywood, and that did not want to cut very easily. For wood, anyway.
Wait, what about the flexi ply?
Oh, well, that's slightly thinner, so it's not a fair test, but
Is that easy?
and that cuts more cleanly, funny enough. Probably because it's slightly thinner, maybe. But yeah, well, there you go. I'll tell you what, though. Let's see what happens when I try and cut this hardboard. This is a little bit thicker, so it's a slightly unfair test, but give us an idea. What do you think?
I think it'll be like the plywood.
Yeah, it's easier. Oh yeah, look at that nice. It shears very, very accurately. It's really clean cut. I like that. Look at that. I could almost make a piece of product by cutting it in this, couldn't I? Look at that.
Yeah.
I like that. Oh. And what about the acrylic? We didn't try and cut, did we?
No.
Another oil-based material made from polymers. You can make polymers from starches, as you know, potato starch and rice starch and other starches from grown material. Ready? Yeah, it shatters though, it shatters.
So a bit like glass then?
It's a little bit like glass. It's that brittle fracture, look. Yeah. Should we do another one? Let's wreck it.
Yeah.
Yeah, it's a brittle fracture. Oh, it's gone.
What about this disc?
Oh, good old Clanad. Oh dear. She's going to be... That's the people who are on there. Ready? I think this is going to be quite easy because it's quite thin and it's a more...
Oh, it's pretty flexible,
yeah, it is,
actually.
because it's thinner, but I think it's a polyethylene. I think it's much more malleable, more flexible. Oh, it doesn't like cutting, but...
I wonder if we can still play music now.
Well, in a microscopic level, there's a layer of metal in there. You can see the reflection. And that's clever.
So that won't go in the CD player then?
No, that's laser technology. Yeah. Sorry, band, whatever that was. It's all gone.
We don't even know.
Oh dear. Oh dear. We'll get done for
Pretty
copyright
flexible
law.
though.
Oh dear.
Oh, you can bend it.
Yeah, and there's a very, very thin layer of metal which has a very small binary message which is converted to music. Amazing CD. Not used now, are they?
No.
Okay, well it's all
Bluetooth.
yeah, well it's all what they call solid state. It's stored actually in components themselves now. So does that help cover things, Jake?
Yeah.
Any more smashing? Aluminium. You can cut the aluminium.
Oh, yeah.
Oh yes, we did that one, didn't we? Okay.
Stainless.
Right, okay, I can tell you what's going to happen here.
It's going to be
It's actually
harder
thinner
than
than the other.
steel.
Yeah, I don't think I'll be able to touch it. No! Ooh, no.
Well, look, I can touch it.
Yeah, watch your fingers. Right, I am putting in, even at the very near point to the lever here, the pin, where there's most of the force, I'm putting in everything I can. I can't hardly touch it.
You need
Stainless
some more
steel.
muscles, maybe.
So yeah, let's do some weights tonight, won't we? Doing a 5-mile run in a minute. But anyway, yes, that's quite
Tough.
resilient, tough. Stainless steel is such an enhanced material over normal steel, and that's the nickel inside it. And they do mix other metals in it as well to make it really, really tough. Oh yes, that's impressive stuff. So, was that useful, Jake?
Yeah.
Didn't cut the tennis ball.
Oh yeah, we should try and cut
The
that.
trouble is, like, this is not a fair test because I can't get inside it. I can't. Oh. Yeah, I can cut it, but that's tough stuff. And that's a combined. Oh, it smells inside that tennis ball.
Oh yeah.
Poor. That's a
Crikey.
combined. So this is not just a butylene. This is mixed with a fabric as well, a nylon fabric on the outside.
Yeah.
But it does shear, but it takes a lot.
I think some of the materials need sharper objects.
Yeah, perhaps some sharper shears. But the material science, combined with the properties of the materials and how they've organised them together, is really quite a clever way of getting the best from a product and making a product last so long. Okay. Does that really help, guys?
Yeah.
You like that, Jake?
Yeah.
Yeah, it's been a bit of fun, hasn't it?
Mm-hmm.
Okay, bye.